this video explain example 1 in the week 5 lecture notes. The example 1 has a truss problem and asking to find the strain energy, internal strain energy. It has a pin support and it has a roller support, and it's asking to find the strain energy that we saw in the previous video. To find this strain energy, it has a pin and roller at point A and at point C, and it has a horizontal load 500 Newton at B, and this has a length of 2 meters and this length is 2 meters. Now for these problems we need to find the member forces. We done it in week number 3. These examples again taken from week number 3, but I'm gonna present here. I'm gonna describe here again how to find the member forces. Now to find the member forces, first we can have first find the reaction forces. Let's say AY and AX. We can remove the supports, and another reaction force is CY. Now to find the reaction forces, let's say we say that sum of the moment at point C equal to 0, anti-clockwise is positive. So in that case we have this 500 create the anti-clockwise moment. Perpendicular distance is a 2 and minus AY, this force that create the clockwise moment, so AY times 2 and therefore is minus. So minus AY times 2 equal to 1000 Newton, and then AY equal to minus 500 Newton. Right, so we just found AY. Now we can say sum of the force in X equal to 0, left to right is positive, so AX is this force is a negative and this 500 is a positive, equal to 0, so minus AX is equal to minus 500 Newton, so AX is equal to 500 Newton. Alright, now last one, sum of the force in the Y upward is positive, so AY is going up, CY is going up. This AY and CY, there are two vertical forces, and we substitute AY equal to minus 500 that we just found, so CY equal to 0, so CY equal to 500 Newton. Alright, so we just found 3 reaction forces. Now once you find these 3 reaction forces, we can draw the free body diagram by putting those forces. So CY is 500 Newton. I think we got this reaction in the minus, so I put positive value and I change the directions. That initial direction was upward, so I put it downward and make it positive. And this force, horizontal force, is 500 Newton, the reaction force, and we have external loading 500 Newton, and this distance is this is A, joint A, B, and this one is a C. And if I have this dimension which is 2 meter on the horizontal and vertical, I think this value could be 8, which can be described as a 2 square plus 2 square, which is 4 plus 4, so that give us 8. Now we can use the joint method to find the member force. So joint A, we can draw the joint number A here, which has a 500 Newton, this on 500 Newton, and this is AB, and this load this force is AC. Now when you have cross here, it is easy to see this AB equal to 500 Newton tension, because you can see these are opposite, so this is the first member force, and the AC would be equal to 500 Newton, and that is positive, so that is in tension. So we find 2 member forces. This member force is 500 Newton, and that is tension, and AC we just find 500 Newton, and that is in tension. Now we can find the member force BC. To find the member force BC, we can use the joint B. Now joint B has a 500 Newton up. We find this tension force is 500 Newton, and there is a force here which is BC, and this triangle here is 2 to square root 8. Now here we can say sum of the force in y upward is positive, so we have 500 newtons, which is this one going up, and the vertical component of this BC can be taken this 2 over square root a. 2 over square root a equal to 0, so the BC value could be minus 707 Newton, and that is in compression. So BC would be 707 Newton, and that is compression. Alright. Now we use the equation of the strain energy. Strain energy equations equal to I think there are three members, so let's say N1 annual, A1, and AE is a constant, so I'm not putting 1 for that, and this is square. N2 square L2 over AE plus N3 square L3 over AE. So if I have 1, 2, and 3, so let's say I put this 1 here for member AB, member AC, so this is 1, member AB is 1, AC is 2, AC is 2, and BC is 3. Right. Alright, in this case we have N1, which is 1 is 500 Newton, so let's say 500 square times the length is 2 meters over AE. I think that is a 2 AE, and we have a number 2 AC. Number 2 AC has a load of 500 Newton, so 500 square times 2 over 2 AE, and plus N3 is a 700, which is BC, so minus 707 square times square root 8. The length of the member A BC is member BC is so this is BC, member BC is square root 8 over 2A. So if I simplify that using the calculator, let's say 500 square times 2 plus 500 square times 2 plus minus 707 square times square root 8 over 2AE, I get the answer is 1206893.24 over AE. So that's your answers, internal energy of the truss members. Thank you very much.